Assalamualaikum to Dr. Nur Rashid. So today, my team and I want to present our assignment. So our title is Active Suspension System. Next. So this is our group members. So first, Firdaus bin Daud. So second, Siti Aisyah binti Badrul Hisham.
Hi, Doctor.
So number 3 is me, Cik Wan Muhammad Najmi bin Cik Wan Muhammad Amel. And we have Muhammad Zulfaqi bin Mansi.
Assalamualaikum, Doktor.
So lastly, Muhammad Nur Amin bin Haji.
Assalamualaikum, Doktor.
Okay, next.
Okay, for our introduction, active suspension system is the one of the automotive suspension on a vehicle. It is used an onboard system to control the vehicle movement of the vehicle wheel relative to the chassis or vehicle body rather than the passive suspension provided by large spring where the movement is determined entirely by the road surface. It is divided into two classes, which are real active suspension and semi-active suspension. Okay, next we go to the first journal that we do the literature summary. Okay, for the first journal that we choose from the active suspension system is the network control for active suspension system. The name of journal we get from the Procedure Computer of Time. The year of the journal is 2019. Okay, for the journal of the methodology that they are used is the first for comparison between two control method, which is for the PID and LQR for active suspension system. Okay, next is a network control for active suspension system using a proposed model of CAN network MATLAB software. For the result of the methodology is using LQR control, the system allow more freedom in choosing the parameter for direct control. Okay, next is PID can provide a good result in case of controlling just suspension cable. Lastly, in network system, the speed of network is low, so that the result shows that the performance of LQR method is better than PID controller. Okay, next we go to the next journal.
So this is our next journal. The title for our next journal is Optimal Control of Vehicle Active Suspension System. The name of journal is Journal of Automation and Control Engineering, year at 2018. So for the methodology, first, comparison between body deflection, suspension deflection, and body acceleration using PID and LQR control method. So the next method is design LQR controller. And the next is do the simulation by using MATLAB software. So the result of the methodology is LQR control scheme give much better result compared to PID control scheme, and passive suspension system as far as ride comfort and suppression of vibration and concern. Okay, next.
Okay, for the third literature review for summary, the title is Constraint Following Control Design for Active Suspension System. So the name of this journal is Mechanical Systems and Signal Processing. The year is 2019. The methodology that the journal used, first one is drive the system to follow a series of servo constraints or control goals which include both equality constraint of the reference trajectory. The second one, inequality constraint of the boundary restriction on the sprung mass displacement. And the third one, constraint following control, which is known as CFC, is applied to drive active suspension system to follow equality constraints. Under the premise of ignoring inequality constraints, no auxiliary variables are required for the control design. So for the result on this journal, The first one is sprung mass motion control of an under-actuated active suspension system. The second one, when only equality constraints are involved, the CFC can be directly applied to active suspension system. The last one is when both equality and equality constraints are involved, the proposed CFC based on diffeomorphism can be used to control active suspension system. Next.
Okay, for the fourth journal, the title is Enhancing Vehicle Suspension System Control Performance Based on the Improved Extension Control. The name of the journal is Advanced in Mechanical Engineering, year 2018. So the methodology that they use in this research is suspension system modeling, the dynamic model of full vehicle suspension system with 7 degrees of freedom is both. Extension control of suspension system is both divided into classical domain, CD, extensive domain, ED, and non-domain, ND. The characteristic variables are chosen to constitute extension set, and according to the corresponding function values range, the major modes are divided. To improve the EC jump nearby the domain boundaries, the Takagi-Sugino-Kam TSK fuzzy control method are used for the methodology, and the outcome for the research is it demonstrate the optimal control means the optimal suspension performance. The extension control effectively extend the control ability which gets the best suspension control performance without minimum values and setting time. By extension control improve the suspension performance, the suspension responses under impulse input can best restrain the root disturbance and fastest return to the stable state. The last one is if the extension control with domain game and the Takagi Sugino TSK Fuji control is adopted, the control ability be extended to the best so that the best suspension system performance is achieved. So next, Jinul.
Okay, for our last journal, the fifth journal, the title is Neural Network Based Adaptive Dynamic Surface Control for Vehicle Active Suspension System with Time Varying Displacement Constraint. The name of this journal is Elsewhere in the year of 2018. Methodology in this journal is used. The system contains a human body model, a quarter vehicle suspension, and a seat suspension model. The variable that is human body mass, seat frame, the sprung mass, the unsprung mass, displacement of corresponding mass, road input, the force that produced by the damper of the cushion, seat suspension, vehicle suspension and tire, and force which are applied to the seat suspension and vehicle suspension. Okay, and then the result is the problem of explosion of 8 order system has been solved using first order filter by using the DSC. And next is to a new approach to deal with non-strict feedback system has been used instead of variable separation method. And then lastly is two simulation examples are implemented in order to prove the merit of proposed control system. And next, okay, discussion. Active suspension system capable of adjusting its parameter value itself by using an actual parameter to the spring and damper to provide better result. Active suspension system is a closed loop system with a controller in loop to calculate how much energy is dissipated or absorbed by actuator. Semi-active system can only vary the viscous damping coefficient shock absorber and do not add energy to the suspension system. They require less energy to function and are less expensive. Among semi-active control devices, magnetoreological MR damper are particularly interesting because of high damping force. They can produce with low power, being possible to operate with batteries, simple mechanical design, and low production cost. Okay, a lot of common vehicle today use passive suspension system to control the dynamic of vehicle vertical motion, as well as spinning pitch and tilting roll. Passive indicate that the suspension element cannot provide energy to the suspension system. The passive suspension system limit the motion of the body wheel by limiting their relative velocities to a rate that gives the required ride comfort.
So for the conclusion, car suspension system allows to ride relatively undisturbed while traveling over rough roads. It also allows vehicle to corner with minimum roll or sway, stop with minimum of brake dive, and accelerate with a minimum of acceleration squat. This dynamic control keeps the tires in contact with the road. From that, active suspension system is the best suspension system for car comfort.
And lastly, for the reference, here is the 5 list reference that we use to search for our journal. So as we can see here, Ukin, Sagi Journal, and the 3 below there. So that's all from us about active suspension system. Thank you.